Hello and welcome back to another IB Math speedrun with me, Vince. And to this speedrun, we're going to be going through the chapter review of the IB Math textbook, Chapter 7. So let's jump right in. Oh boy, okay, so I think we have some questions, a lot of questions to cover. So first, solve the following questions. And we're going to start off nice and easy. 4 to the power of x minus 1 minus 3 times 2 to the x plus 8 is equal to 0. So we can evaluate this into 2 times 2x minus 2 minus 3 times 2 to the x plus 2 to the 3 is equal to 0. So this is equal to, it's equal to 1/4 times 2 to the 2x minus 3 times 2 to the x plus 2 to the 3. Okay. So what we're saying is that effectively we can treat this as a quadratic. So we have 2 to the x is equal to negative b, so that's plus 3, plus or minus the square root of b squared, which is 9, minus 4 times a, the coefficient of a is 1/4, times c, the coefficient of c is 2/3, all over 2a, which is 1/8. 1/2. So this should be equal to 3 plus or minus the square root of 9 minus 8, so 3 plus or minus 1 over 1/2. So this should be equal to 6 plus or minus 2. So 2 to the x equals 6 plus or minus 2. So 2 to the x is equal to 8 or 4. So x is equal to 2 or 3. So yeah, I think we have two answers for that. So that seems pretty good. Okay, on to the next question. We need to solve the following logarithmic equation. Log 2 to the x plus log 2 to the 3 minus log 2 to the 5 is equal to log 2 to the 6. So we can do this by simply adding up all the logs. So we get log 2 to the 3x over minus 5 minus 6, so that's minus 30, is equal to 0. So in other words, 3x over 30 needs to equal 1. So x must equal 10. So yeah, because 2 to the 0 must equal 3x over 30. Yeah, that's correct. Okay. Next question, we need to solve for x. So we have log 2x is minus 3 over log x to the 2 is equal to 4. And so we need to use the log trick that log x over 2, if we're dividing by that, it's actually multiplying by log 2 to the x. So we have 3 log 2 to the x is equal to 4. So we have, in this case, where do we start? Log 2 to the x over x cubed is equal to 4. Yeah, so then we have 2 to the 4, in a sense 16 is equal to 1 over x squared. So x squared is equal to 1 over 16, so x is equal to plus or minus 1/4. So that should be the answer. Plus or minus 1/4, where are we? Yep, that's correct. On to the next one, so number 4. So we're given that y is equal to 2e to the 3x minus 7e to the negative 3x. Show that the second derivative, d squared y over dx squared, is equal to 9y. Okay, so let's just get the second derivative and then prove this later. So we have the first derivative, dy over dx, is simply equal to 6e to the 3x plus 21e to the negative 3x. And so d squared y over dx squared is equal to 18e to the 3x minus 63e to the negative 3x. And so we can factor this into 9 times 2e to the 3x minus 7e to the negative 3x. So as you can see, it's clearly equal to 9y. So yeah, that was cool. And on to the next one. So the next one is determine the values of ln x given that ln x minus 1 over ln x is equal to 4. So we just need to determine the values of ln x based on this. So this is actually pretty simple. It's that ln x squared minus 4 ln x plus 1 minus 1 is equal to 0. And then we can simply solve like a quadratic. Ln x is equal to 4 plus or minus the square root of 16 plus 4. Yeah, because minus 4 I see, over 2a, which is just 2. So this is equal to 2 plus or minus, this is 20, which is 2 root 5. So this is 2 plus or minus root 5. And so that should honestly be the answers. Yeah. So that should be correct. Yeah, it's correct. So now on to the next one. We have, given that y is equal to the absolute value of ln x, show that dy over dx is equal to ln x over x ln x. So for absolute value functions, when we're getting the derivative, we need to split them into their piecewise variants. So we need to say that this function is equal to ln x, for which ln x is greater than 0, and negative ln x, for which ln x is less than 0. Or greater or equal to 0, technically. So if we get the derivatives, we get 1. The derivative of ln x is 1 over x, for ln x is greater than or equal to 0, and we get negative 1 over x, for which ln x is less than 0. So now we got to combine these two functions back together. So how do we do that? We can simply use the absolute value trick, because these both will equal 1 over x, and if we simply multiply this by ln x, which is the whether it's positive or negative over the absolute value of ln x, or the other way around, it doesn't matter, then we will get the same thing but absolute value. So we do end up with ln x over x times the absolute value of ln x as the answer. So yeah, that's cool. Next, find the value of the limit between 3 and 1 of 2x minus 3 times the square root of x squared minus 3x plus 3 all over the same x squared minus 3x plus 3 dx. And so we can use integration by substitution. U is equal to x squared minus 3x plus 3. Du over dx is equal to 2x minus 3. So we can rewrite this limit as what's 3 squared, 9 minus 6 plus 3 is 3 plus 3 is 6, and then 1 minus 3 plus 3 is just 1. And then we can rewrite this dividing by 2x plus 3 as u to the 1/2 over u. And so this is simply equal to u to the negative 1/2 du. So from this, we can get that this is equal to 6 and negative 1 of 2 u to the 1/2 And so this is simply equal to 2 root 6 minus 2. Oh no, I've made a mistake. This is only 3, yeah. Oopsies. So this is only 3. So the limits are actually the same. So this is just 2 root 3 minus 2. So that is the answer. Next, we have find the equation of a tangent to the curve f of x is equal to e to the x over 2 minus 1 that passes through the origin. So we need to find a tangent of this curve that passes through the origin. Interesting problem. Okay, so let's get the derivative. F of x is equal to, what is this? E to the x over 2 minus 1. So this would be 1/2 e to the x over 2 minus 1. So this is the gradient of the curve. So we know the curve is going to have a format y is equal to mx plus c. And so we know that it must be able to pass through 0, but it also has to pass through this curve and be a tangent. So if it passes through the origin, actually, okay, so we know the constant equals 0. So we know the curve has to be of the form y is equal to mx. Since it passes through the origin, there should be no y-intercept. So it means that this point should also lie on that. So since we have the gradient, 1/2 e to the x over 2 minus 1, and a point on this curve, we need to find a point on this curve that also meets this condition. So we can simply punch in e to the x over 2 minus 1 is equal to 1/2 e to the x over 2 minus 1 times x. So dividing both sides by this, we get 0 is equal to, because this e function will never reach 0, so 0 is equal to 1/2 x. Oh, sorry, this is 1 is equal to 1/2 x. Oh, okay, so 1 is equal to 1/2 x, so x is actually equal to 2. So if this is the only value for which it will work, so if we plug it back in here, we get y is equal to 1/2 e to the 2 over 2 minus 1 times x. But e to the 2 over 2 minus 1, which is e to the 0, is equal to 1. So this is simply the curve y is equal to 1/2 x. So yeah, that was pretty good. Next, determine the value of x squared e to the x over 2, which looks like integration by parts twice. So u is equal to x squared, u prime is equal to 2x, v prime is equal to e to the x over 2, v is equal to 2e to the x over 2. So this is equal to 2x squared e to the x over 2 minus the integral of negative 2x, negative 4 x e to the x over 2. Okay, and so now we need to integrate this. So we get u is equal to negative 4x, u prime is equal to negative 4, v prime is equal to e to the x over 2, v is equal to 2e to the x over 2. So we get this is equal to plus 8x e to the x over 2 minus the integral of 4e to the x over 2. No, minus the integral of 8e to the x over 2. Which is simply equal to, we add this. Plus minus, so we do have a minus 16e to the x over 2. So minus 16e to the x over 2. So this should finally equal 2 times 2e to the x over 2 times x squared plus minus 4x plus 8. Yes, because we have to flip these symbols around. So this would be plus, and this would be a minus. So 2e to the x over 2 times x squared minus 4x plus 8 plus c, of course. So yeah, that was pretty cool. And we can move on to the next one. Next question asks us to solve the equation 3e squared x plus 11e to the x is minus 4 is equal to 0, giving your answers in the form a, ln b. And next, solve the equation ln x squared minus 5 ln x minus 36 is equal to 0. Okay, this is an interesting problem. The first one, 3e squared x plus 11e to the x. I hope this is not a typo, but I have a bad feeling this is a typo. Bet it's a typo. Uh-oh. Yeah, it's a typo. Oh, I looked at the answers. It's a typo. This is 3e to the 2x. So again, we could factorize it or plug it into the quadratic equation. Either method works fine. It's whatever you prefer. But I'm going to factorize it because I know this is 3e to the x plus 4. And this is minus 1 times e to the x. So we have our two possible solutions. Our e to the x is equal to 1/3. X is equal to ln 1/3. And e to the x is equal to negative 4. X is equal to ln negative 4. Is that possible to ln negative 4? I think the answer is no. I think this isn't a solution. Very sadly. So I think the only solution is x to the ln 1/3. Yeah, because ex to the negative 4 is no solutions. Okay, next, the other one was ln x squared minus 5 ln x minus 36 is equal to 0. Factorize into ln x. Ln x minus 9 and ln x plus 4 is equal, yeah, because 36 negative 5. So we have ln x is equal to negative 4, x is equal to e to the negative 4, and ln x is equal to 9, x is equal to e to the 9. So these are our two solutions for these. Yeah, that's correct. Okay, on to the next one. Describe a series, oh no, describe 18. Describe a series of transformations that map the graph of the function f of x is equal to log 10 base 10x onto the graph of y is equal to log 10 2x plus 100 cubed. And what I mean is this is log 10x, and we need to map it onto log 10 times 2x plus 100 cubed. And this looks daunting until you realize that you can actually remove this from the front and simply add it to the front of this function. So this will stretch the function, and so this is equal to 2 times x plus 50. And so if we say that f of x is equal to log ax, this new one is equal to y is equal to 3 f of 2 times x plus 50. So what can we get from this? We know that there is a shift to the, sorry about that, there's a shift to the left of 50. So this is shifted 50 units to the left. It has a vertical stretch of 3, and it has a horizontal contraction of 2. So if we contract it by 2 horizontally, stretch it by 3 vertically, and translate it 50 units to the left, this will get us the new function. Oh, next, find an expression for dy over dx. So again, y is equal to log 10 2x plus 100 cubed. We need to find the derivatives. So this is equal to 3 log 10 to the 2x plus 100. And then we can say that this is equal to this is equal to 3 times, or in other words, 3 over ln b times x. So ln 10 times 2x plus 100. So this should be the derivative. Just remembering the rule that, of course, log d over dx log bx is equal to 1 over ln b times x. So x ln b. Is that correct? Ooh, it's a bit different. What have they done? Oh, I forgot to... Okay, wait, yeah, no, I've made a mistake. Yep, because I forgot to differentiate inside, so we also have to multiply by this. So this should be equal to 6, actually, because this would be chain rule. So if we have ax plus b log b, c, ax plus b is equal to a over x ln c. So yeah, that's it. Next, 20, we need to consider the curve of y is equal to x cubed e to the negative x. So we need to prove that the point 3, 27 e to the negative 3 is a maximum. And so we need, and find the equation of the tangent of the curve at the point where x equals 1. So tangent at x equals 1, not 7, 1. And so maximum here, tangent here, and give it in the form ax plus by equals c. So let's get the derivative of this. So this is product rule, so we have dy over dx is equal to 3x squared e to the negative x minus x cubed e to the negative x. So we need to prove that this point is a minimum. And we don't need to, we just simply have to punch it in here. Actually, we need to get the second derivative too to prove that it's a minimum. It's equal to, what is this? This is 6x e to the negative x plus 6x squared e to the negative x. No, actually, it's just 6x squared e to the negative x plus x cubed e to the negative x. Okay, interesting derivative. So we need to punch 3 and 3, just 3 in, more or less. So 3 times 9 e to the negative x e to the negative 3 minus 27 e to the negative 3. So these two cancel out. So this will equal 0. So it is a turning point. Now we need to check whether it's a minimum or a maximum. So we have 6 times 3 times e to the negative 3 plus 27 e to the negative 3. As you can see, this is going to be positive. So this means that this is a minimum. So it is indeed a minimum. Next, we need to get tangent at x equals 1. So we'll use this formula here, which is 3e to the negative 1 minus e to the negative 1. So this is equal to 2e to the negative 1. That's the gradient of the function. So we have y is equal to 2e to the negative 1x plus c. And we need it to pass through the point on this curve where x equals 1. And so that is, it needs to pass through y is equal to e to the negative 1. So e to the negative 1 is equal to 2e to the negative 1 x, that's 1, plus c. So c must be equal to negative e to the negative 1. So we have y is equal to 2e to the negative 1x minus e to the negative 1. And we need to express it in the form ax plus by is c. So we can simply say y minus 2e to the negative 1x is equal to negative e to the negative 1. Yeah. Oh, okay. So I guess we could also rearrange it into the form e to the y. ye minus 2x is equal to 1, which also works. So just multiply everything by e. Or ye minus 2x minus 1 is equal to 0. Yeah. Okay, and then we need to move on to the, still two more. Okay, so there's suitable substitution. Find the exact value of the integral 1/3 to 1/6 of dx over square root of 1 minus 9x squared. Okay, interesting. So this is, of course, we need to substitute using sine. So we're going to use the substitution sine u is equal to 3x. It's a suitable. So we have sine squared. Yeah, okay, so sine u equals 3x. So we have, if we convert this, we get that new bounds will convert later, but we get 1 over, oh wait, I gotta differentiate this. So we gotta say du over dx cosine u is equal to 3. Yeah. So we have 1 over cosine u times cosine u over 3 is equal to du. So we get du is equal to 1/3. I mean, not equal to 1/3, but we get that this evaluates into the integral of 1/3 du. So next we got to convert the limits. So we have 1/3, so 1/3 x. So sine u is going to be, so this is going to have to be sine to negative 1 of 1. And this one will be sine to the negative 1 of 3 times 1/6 is 1/2. So we have sine to the negative 1 of 1/2. So if we convert this out, we should get, so wait, sine to the negative 1 of 1 is pi over 2. And sine to the negative 1 of 1/2 is pi over 6. So why are they asking, oh, because, okay, because it's pi. So of course, 1/3 u. So we get the value of pi over 6 minus pi over 18. So this is equal to 2 pi over 18, which is equal to pi over 9. So this is the exact value. And using technology, get it to 3 significant figures, just punch in pi over 9. So we get 0.349 in my case. Just check that's correct. Yep, pi over 9, 0.349. And then on to the final question. And the final question is the first 4 terms, oh dear. The first 4 terms in an arithmetic series are log 2 343, log 2x, log 2y, and log 2 1331. Find the value of x. That's not bad actually. This is not a bad question. So we have log 2 1331 minus log 2 243 is equal to 3 times the difference between each term. So we have log 2 1331 divided by 243. So log 2 5.48 is equal to 3 times the difference. So we have log, the difference is equal to log 2 times the cube root of that answer. So the log 2 of 1.76. And so to get the second term, or x, we need to simply multiply 1.76 by 3.43. So we have 343, times 1.76 is equal to, I got 604.6 as my answer. Just check that that's correct. Oh, sorry, I wrote 243 when this should be 343. Oops. So the cube root of 1331 divided by, 1331 divided by 343 the cube root of that is only 1.57. So if we have 343 times 1.57, we end up with 539. So that should be our answer. Yeah. So that is all for today's speedrun. I hope you enjoyed, and I hope you learned some calculus or math along the way, and I hope to see you in the next one. See you then.